Hey everyone, welcome back. Today we are going to dive into creating a balanced Y-to-Y three-phase system in Matlab Simulink. By the end of this video, you will know how to set up this type of system, simulate it, and analyze the power characteristics. So if you are ready to strengthen your knowledge in three-phase power systems, let's get started. So as you can see on my screen, we have the Matlab opened and we have the Simulink here. So the first step is to set up the Simulink model. So we have already opened the Matlab. So let's create a new Simulink model. So we click here on Simulink. We click here on blank model. Let me maximize it. So here we have a browser. On the browser, that's where we get all the equipment. So for the creation of a balanced Y-to-Y phase system, we are specializing on the simscape under electrical. That's where you get almost all of the electrical components which you need for the construction of the model. So for us to build a balanced Y-to-Y phase system, we need to have voltage sources, AC voltage sources, with a phase difference of 120 degrees. So instead of looking on the electrical components, we can just click here and then we type. So we need a voltage source, 3 voltage sources. Need a voltage source, AC voltage source, this one. So we need 3 of them. We copy and paste. That's the second one. We need the third one. Right. So we need to give each of these a phase angle. So this one, we give it a phase angle of 0 degrees with a frequency of 60 and a peak amplitude of 100 volts. This one, we give it the same peak voltage, since the peak voltages are the same frequency, but the phase, we give it a positive 120 degrees. We click apply and then OK. And then this one, we give it a negative 120 degrees, same frequency, same amplitude, and then apply. Right. So after having our voltage sources, we need the ground. So we simply type ground. We get this one, put it here. So we need to connect our voltage sources to the ground. Like this. Like this. Like this. Right. So afterwards, we need a voltage measurement. So we type measurement, a voltage measurement. We click the voltage measurement. We put it here. We also need a current measurement. We also need a power measurement. A single phase power measurement. We also need a 3-phase power measurement. 3-phase power measurement. We also need a VI measurement, so we type measurement. We also need an RLC circuit in series, so we take this branch in series, we rotate it right. Let me adjust the voltage sources. So the first voltage source is connected to the current measurement. The second voltage source is connected to phase B. The third is connected to phase C. And the current output is connected to phase A. This one, sorry, this one, yep. And we connect the RLC to the 3-phase VI measurement, and we need to ground our RLC like this. So this is our voltage measurement. We connect the voltage measurement, it's negative, to an earth, so we need another ground, and we connect its positive to the first voltage source, and then we connect the current measurement to the power measurement on the I side, and the voltage measurement to the voltage part of the power measurement of a single phase. And then this is the phase voltage between A, B, and C. So the phase voltage is connected to the power measurement V, and the phase current is connected to I. So we set up our system like this, right? So what we need, because if you run the simulation, we need to see the results. So we need displays. We type display. So we need almost 7 displays. So we just copy and paste the first display will be connected here. The second display will be connected here. The third display will be connected here. The fourth display will be connected here. Right. So we also need to measure voltage between two phases A and B. So we need another voltage measurement, so we type measurement, we click on voltage measurement here. So we connect the positive of the voltage measurement onto A and the negative onto B, and we need its root mean square value, RMS. We type RMS. Here we have our RMS, and then we display it. Right. Same applies here. We also need the RMS values of the single phase current. So we need an RMS for the single phase current and the RMS for the single phase voltage. So put it here, we put it here. So we connect this to the single phase voltage, to the single phase current. We need to display this RMS value. We need another display. Here. Right. So for our simulation to run, we need our power GIU, our power GUI. So we type power, and we locate it anywhere. We can locate it here. Right. So it depends on what we need to measure. If you want to see the phase voltage graphs, three-phase voltage graphs, or three-phase current graphs, we may put a scope. So we need a scope with two inputs. So there is a plus sign which appears somewhere here. Or we can double click it, and then we go to file, a number of ports, we'll put 2. That's the easiest way. This is to measure three-phase current, and this one is to measure three-phase voltage. So it's up to your question or up to your exam or assignment to change the values. If you are given 60 Hz, you must put 60 Hz. It depends on the number of harmonics which you want as well, but make sure that your frequencies are the same: 60 Hz, 60 Hz, 60 Hz, and everything is the same. So if you run your simulation, the stop time is 10 seconds, so that's why it's taking some time. You can simply change the stop time to whatever you want for you to be able to make observations, but normally you can use a stop time which is the inverse of frequency. So if you want to use 1 over 60. For argument's sake, let's just use 1 over 50, which is 0.02, or 0.04. We just use 0.04, and we run the simulation. So on the scope, that's where you see all the graphs. So on the graphs, you can go on to fuel, legend. You can see that this graph, this one, and this one. So you can see these graphs are the three-phase VI measurements: signal 1, signal 2, signal 3. Each one is corresponding to each color. So thank you very much for watching. Make sure you hit the like button and subscription button. Thank you.